Students, today I'll show you how to read a data point within an equilateral triangle. Equilateral triangular method is commonly used to represent ternary concentration in liquid-liquid extraction or solvent extraction system. So let us first draw an equilateral triangle. So this is an equilateral triangle. The top point represents component C. This point represents component A. This is component B. Now the vertex or the vertices represents 100% purity of that component. So this means the top point represents 100% of component C. This is 100% of component A. This is 100% of component B. Now the rule says that if there is a given point within the triangle, suppose this is point P, the rule says that the sum of the perpendicular distances of this point is equal to the altitude of the triangle. So it basically means if I draw a perpendicular from this point P into side BC, so let us suppose this is point Q, this is point R, this is point S. Okay, so sum of the perpendicular distances from the interior point P, PQ plus PR plus PS is equal to the height or the altitude of the triangle. So we'll get the height or the altitude once you draw a line from point C into the opposite side, which is AB. Let us suppose this is point D, is going to be equal to CD. So PQ plus PR plus PS is going to be equal to CD. That's the rule, the geometric rule. Fine. Now if the altitude CD is made to represent 100% composition of a ternary mixture, then the perpendicular distance can be made to represent percentage of the three constituents of the mixture. And I'll show you how you can use this rule to read a point or plot a point from a liquid-liquid extraction equilibrium plot. Okay, so I have to show you in detail. So to do that, let me draw the diagram once again. Just a minute. This is an equilateral triangle, an approximate one. Okay, C, A, B, and this is the altitude or the height of the triangle. So let us suppose this is D. Now how can you make use of this method to read a data point or to plot a data point within the equilateral triangle? Fine. Now this altitude CD, let us suppose divided it into 10 equal parts. Okay, so for the sake of clarity I have just drawn it separately. So this is the equilateral triangle CAB. This is the height or the altitude of the triangle, and this altitude is divided into 10 equal parts. Okay, now as I mentioned earlier, the vertex represents 100% of that constituent. So the opposing side, the base AB, represents 0% of C. Okay, so once you divide the line CD into 10 equal parts, each of the horizontal line represents an increment of 10%. If you just deal in percentage, or if you want to deal in weight fraction, then each of the line represents an increment in 0.1 weight fraction. So if this is 100%, the base AB is 0%, it means this line is 10% of C, this line represents 20% of C, this is 30%. In this way you keep going, 90%, and the top one is 100%. Okay. Similarly, for the other one, the same triangle CAB, from B you have drawn the height, okay, and this altitude is split into 10 equal parts. B represents 100% pure B. The opposite side CA or AC is basically 0% of B, and each of the line represents an increment in 10% of B. So it basically means this line is 10% of B, this line reaches 20% of B, and in this way you keep coming, this is 90% of B, and the point B basically represents 100% of B. Okay. Now you go ahead and then again you draw an altitude, okay, from point A into the opposing side BC. Point A represents 100% of A, the opposite side BC is 0% of A, and each of the line means an increment in 10% of A because you split it into 10 equal section. Okay, so this is going to be 10% of A, this is 20%, in this way keep coming, this is going to be 90%, this point A is going to be 100%. Okay, so once you draw all the lines within the equilateral triangle, the final graph will look like this. Okay, it looks like, there are a lot of grid lines within that one, but I have already shown you step by step how can you reach to this point. Okay, now to read a point, suppose there is a data point on this line. Okay, this is the point, and you are asked to find out what is the concentration or what does this point represent in terms of its concentration. Okay, suppose this is point P and you are asked to find out its corresponding concentration. So in terms of C, you have to start reading from the base. This is point C, this is point C, it basically means 100% of C. You start reading from the base, it means 10%, from this is base is 0%, from there 10%, from there 20%. So C is 20% corresponding to point P. This is A, 100% of A. This point is B, 100% of B. Now with respect to B, if this is 100%, the opposite side CA is 0%. So the base is 0%. So from here you start reading. This is 0%. This is an increment of 10%. This is an increment of 20%. So with respect to B, the point P represents 20%. Okay. And then you try to find out the corresponding concentration of A. What would be the concentration? It's quite easy. This point A represents 100% of A. The opposite side BC is going to be 0%. Each of the line represents 10% in increment. So let us just read it. Okay, calculate. This is 10% of A. This is 20% of A. This is 30% of A. This is 40% of A. This is 50% of A. And this point represents 60% of A. So this is 60% of A. And if you add A plus B plus C together, 60 plus 20, 80 plus 20, 100. So in total you will get 100%. So the sum total is going to be the 100%. And in this way you can easily read any data point within an equilateral triangle, which is extremely handy because in liquid extraction or in solvent extraction problem, we have to deal with three concentrations corresponding to three components, okay? And if suppose equilibrium data is given separately in terms of weight fraction or weight percentage, the same concept can be used to locate extract line and the raffinate line, and you can complete the graph. Thank you.